Well, hello and welcome to Genomics in the Cloud Book Club, Week 11. I'm your host, KT Picard. In today's meeting, we'll be running single workflows at scale, building on the previous two chapters that were shared by Lynn and Mathieu with WDL. We'll be now running these with a new pipeline API that uses Cromwell. We'll run these in real time and have some additional resources and then a discussion at the end. So here now is chapter 10. Chapter 10 expands on the use of Cromwell and a new, new in quotes API called the Genomics Pipeline API, or PAPI. Your pronunciation may vary, and we'll get to that in a little bit about why it's not terribly important. But as you can see in this diagram, what it's showing is that the inputs on the left are sent into Cromwell, the job manager. But then instead of running the job directly in Cromwell, Cromwell passes these things through the Google API and then spawns or sets off numbers of VMs so that you can expand your workflow and use as many VMs as you need to. We'll talk about this scatter and gather algorithm, but this is the basic concept that we're moving to. Ultimately, we'll share a second method to do this, and then this is all build up for next week's discussion around Terra. So a small differentiator between things that are executed locally, which we've been doing to date, and things that are done using this new method of execution. So on the left, you're looking at execution inside a single container where Cromwell and the Docker image, everything is self-contained. In the diagram to the right of the dotted line, you'll see a similar picture. The difference is now that the VM, which indeed could be the same VM, is now acting as the master. And then once you've set that up, then the number of instances that you set up, PAPI then sends out those instances, sets them up, and then farms out, if you will, the work to those other VMs. And so you can see PAPI in the middle here to do that. And as I say, in the second portion, we'll learn that you can even instigate or set up this master VM from anywhere, even including your desktop. So to get this going, you'll need to make some changes. So to enable these APIs, or application programming interfaces, inside of the Google Cloud platform, you'll need to go and turn these three things on: the Compute Engine API, the Genomics API, and the JSON API. The easiest way to get there, and I'll bring that up in just a sec, is to go into the Google the console. Thank you. There's the word. And then we can do that by, if you move down to the API section. So under APIs here, there's a library, and you can go into that library and then start typing. What I wanted to point out here is that the Genomics API, you can see it says deprecated, meaning that its functionality will be removed. And the book fully discloses this and says that it's moving toward the Google Cloud Life Sciences API. Nevertheless, for the purposes of running the commands and for the exercises in this book, we push into this, and when we click into it, you can see it's already been enabled. But if I needed to, I'd enable it there. But keep in mind that the word deprecated means that it could be removed in the future. And that's kind of what the discussion is down here. But it still works for today. So getting started, these are the commands that we use. We're using the similar kind of ideas of creating a sandbox. There's a configuration file that we'll walk through in detail in a moment. There's some export or configuration variables that we'll put together there. And you do have to make some changes to the my-google configuration file, where you change in the kind of default from what's in brackets to your project name. So we'll walk through that. So I put together some of the commands here. So I'm opening up a console window, and we'll start by moving through those commands that we just looked at. So the first one is to show you the configuration file itself. this is the bit that tells Cromwell where to execute things and the name of your project. So we'll come back to this in a moment. There's some things here that we need to edit so that they're specific to our project. We're also making a sandbox here. So I've done this before, but you can see that I've made this thing called sandbox for chapter 10. And of course, we're copying, included with the distribution, copying that to a personal copy. It's named my-google.conf. You can call it what you want to, but we do use this name in some later commands. I'll edit the a different copy of it that hasn't been edited, and point out that there are some places in here where you need to make some changes. There are actually 4 places in the file where you need to put in, where it says Google project ID, you need to add yours. There are a number of environmental variables that you need to export, so we'll do that here. And this just makes it easier for the commands to execute. So there's one for the configuration file. Here's one for the bin file or executables. Here's one for the directory to the workflows. And then lastly, to your bucket. This kind of points out one of the gotchas that we just discovered before the call, which is sometimes your editors change characters that you don't want it to. And in this case, these little quotes are not matched, or they're matched quotes instead of single quotes. And that's a gotcha. You want unmatched quotes. You want the ending quote and the beginning quote to be exactly the same. But in the editor, it's changed those. So it's something that you have to watch out for. Okay, and we'll talk about another gotcha that we figured out just before the call as well. So if we take a look at the inputs that this is going to be using, so you can take a look at this file, which shows that there's different components here that are described in this JSON file, the index file, the BAM file. There's the Docker image that we're trying to call, the reference genome. These are all things that we typed by hand in previous chapters. And this time we're just putting them inside of a JSON file and calling it as part of the inputs. That then goes into this command right here. And that's actually running, let me pull it over. And that's actually running Cromwell with the WDL file and also those inputs that we just talked about. Let's take a look at that WDL file just for fun. So here's the WDL file itself. Looks very similar to the work that Mathieu showed us last week, where there's a number of commands, their files, and how it is that we're putting them together. So next, we would run this entire command. I did that before we got started so that we could, it takes about 10 minutes to run. So we started this before this meeting so that you could see what it looks like and how we can take this apart. It ran to success, and ignoring some of the stuff down at the bottom, what you're looking for are things like success. And if you look in here, you'll see that the output file was created, and then things are shutting down, and the actor is being released, and everything is being shut down. So there it is. That's what I'm looking for. Workflow finished with status exceeded. And you can see that, this is kind of step one in the process of how do you figure out what in the world is happening, given that there's so much information here. So the other part that I wanted to share, that even getting to this point can be a challenge. The part that we found just before the call started is yet another substitution in the editor, and that is the single being moved into the 2- or the N- being moved to the M-, if that makes more sense. What the editor was doing was taking a single dash and making it a double dash for us. And with the good folks, the help of the good folks on the call, we figured out that what looked like 1 dash was indeed 2, and was preventing us from watching the command run. It was treating the double dash as an input into a program rather than the configuration or the argument into Java. Anyway, thanks to the group for figuring that out. So that's kind of takes us to the first part of this exercise of using Cromwell, and these are the commands that we executed along the way. I should mention there is this one step that's important, which is the authentication step, and you can run this command to eliminate having to retype all the passwords, usernames, and passwords. It asks you if you want to continue. You say yes, and then it asks you to go to a website, paste in a code, and that code then creates the authentication files in your VM so that it passes those things along. We talked earlier about how you can check the status of how many things were running. If you go into your dashboard, in your console dashboard, it will show you a number of things. One that you have a number of jobs running, so it'll show you the VMs. We'll come back to that. But it also, if you wanted to look at the number of CPU cycles, it would show you a spike there. But it kind of begs the question: isn't there a better way that we could watch this thing run? The answer is yes, and we'll talk about that in one slide. First, though, a discussion about using VMs and cost savings and trade-offs. The book does a nice discussion about talking about the difference between the number of processors that you use and their cost. And I wanted to talk about 3 suggested cost-saving optimizations that the book goes into some detail about. And these are 3 methods that you can use to figure out how many processes you should use in this scatter and gather workflow. So, and the first one is dynamically sizing for allocating resources. And there's some code that you can use that evaluates the size of the files before you request your VMs. And so you can minimize the amount of resources required for running. And so the book shows some of the math that goes behind that. Mostly this is around file sizes. The second one is using file streaming tools. And this is primarily used or made available through the use of buckets or Google storage. There's a parameter called localization optional, and you set that to true so that it understands whether it should virtualize the resources that it can. And storage, of course, being the most obvious, so that you don't have to copy the files onto each VM. So that's a huge time savings there. There's a discussion about the fact that this is a GCP only command, that it's not available really in all different cloud environments. If you're running this in AWS or Azure, it won't work the same. Also to point out that the Picard tools that are bundled with GATK don't make use of this command. That's a small point, but an important one. And it points to this idea of performance versus portability, and these are trade-offs that we make when we're building systems. Is that sometimes the performance wins out or the portability, and this is one of those cases. Also wanted to point out about this localization optional, and along with all the other commands in WDL that Cromwell is executing for things that are virtualized. If you're running this on your laptop, for example, it understands to ignore those options and to run things locally. So it's clever that way, and it sees, oh, if I'm running this on a bunch of VMs, I'll use the localization, but if I'm running locally, it knows to ignore them. So the idea of doing sub-testing or unit testing, as we've talked about locally, works very well with this environment. The third one is the use of what GCP calls preemptible VM instances. I think Amazon calls them spot instances. And what they are a lower cost method of requesting VM resources. They're, as you can see, 20% of list price. So if you're paying $1 a minute, it's 20 cents a minute, or name your price. But the idea is that it's much less expensive than using an instance that stays up the whole time. It has pluses and minuses. The plus is it's a lot less expensive, and if you're running a few samples, it may not make a difference. But if you're using Nomad or 1,000 genomes or UK, Genome UK, where you have 100,000 examples, this is a big difference. And again, the trade-off of here, price and performance, is that if somebody else is paying the full price for these VMs and you are not, Google retains the right to bump your job and to kick it out for somebody who's paying more. And so that's the trade-off, is that you can receive VM instances at much lower cost. But of course, the challenge is that how do you restart and get things back to where they were? So a couple of points there. There is, in just the last week or so, Geraldine, the author, pointed out that there's some checkpointing, which allows you to save your progress. This is now part of Cromwell. It's not covered in the book how to do that. So that allows you to work up to a certain point and maintain it so that you don't have to redo it all again. Imagine a 24-hour job and losing it in hour 23. Also, there's commands inside that specify how many times you restart before you give up, and just say, I'm not going to use a preemptible instance, but I'll actually pay full price. And at the Broad, they use the number of 3. So after 3 times of being out at bat, if you will, it decides that it uses the full cost instance. So that's 3 ways to reduce costs as you're using this scatter and gather. But all of these things, it's important to understand that you can't go on to gather until all of the jobs are completed. And so again, trade-offs of how much time you want to spend, going through this. What you don't want to end up is, Zeno's paradox, where you just keep going and you never get there. So, okay, so a little way around this, I should say a better way around this is to use another program called WDL Runner. WDL Runner abstracts yet another level out and allows you to launch the master VM and then the other ones from there. So what you're looking at is a diagram on the left with the same inputs as before, but the difference is that WDL Runner then fires off the master VM, still uses PAPI as before, but then the same workers are in that environment. So we'll take a look at that. We have to add some additional environmental variables to make this work. There's some funkiness with the compute zone that we'll get into. That's the region here, and this is the command itself, and we'll do that. Okay, so on to the second part on WDL Runner. We'll add these export variables. And here again is one of those places where you want to watch out. The editor made a little change, and we don't want those matched quotes. And you'll see it'll pass a warning, and we'll see here in just a moment. There's a conflict between specifying the region using this gcloud command, and also with Google Cloud itself. So I'm going to paste this and make a quick change to it. You'll see that it'll have some problems with it. And the reason is that the arguments aren't recognized, because it turns out that the spaces in this inputs from file command, it doesn't like to see spaces between these commands. And so we're just going to take those out and run it again. And you can see here I'm mousing over the workflow options. So we'll take out those spaces, and then the workflow inputs, and we'll take out those spaces. Okay, and then outputs, we have to do it one more time. So there's outputs. Same thing. So in the environment variables, there's 2 pieces there. Outputs are part of environment variables. So we'll put those together. Oh, I see it. I see the error. Okay, good. I'm glad we did this. So under the regions, there's a difference between region and zone. And the region is US West 1, so that's gonna be a problem. The B represents a specific area, and it doesn't like that. So let's take that out. Great. Okay, so let's fix that, because that was my error. So you can see I have it here, and a good point where the regions only want to see the region and not the zone. So Don't tell it where in the region, just tell it the general region. So we've started this, and it gives this thing called an operation ID. We're going to copy that and use it later to see how this thing is moving along. And this is monitoring WDL Runner, and so we'll change to the WDL Runner directory. And now we can take a look at a let's put this back in. And now we'll take a look at a shell script that can show us what's going on. And this is much more helpful as it's putting the jobs together. So this checks every once in a while and goes to sleep and checks again. There we go. So things are running right now. We'll go back to the slides and take a look. Okay, so to review, here's the things that I exported. Don't forget to include the ones from up above. There's an idea here where you have to remove the compute zone to remove this issue. And I'll fix my slide. Let's take out that dash B because that doesn't help anyone. You can see that, right. And as I mentioned, make sure you get rid of the spaces in these commands because it doesn't like in the dash arguments, it doesn't like spaces between the comma and the next argument. When you're running the WDL Runner, the monitor, you can go back to the console and look at the number of workers that are running. And compared to the last time that we ran this, you'll see that there's one additional WDL instance, and that's actually the master instance. And so there's one more that's running. And the advantage here is that you could even set this off, like I say, from your laptop. And I did it from the Google VM, but just as easily could have done it from my laptop. And it would have, again, created this last VM, which is the master that spawns off and creates these workers. There's output then. It's kind of a labyrinth of files, but you can walk through and look at the logging and output, and we'll take a look at that next. And this is a web-based view of the storage inside of your bucket. And here's mine. So we created a directory called WDL Runner. So if you go into WDL Runner now, you'll see these files. And it was something called test. And there's a couple of instances here. And there's the logging. And then you can take a look at the log file itself. So to wrap up here, there's additional documentation about Cromwell. I pulled the main ones from the book. There's a tutorial. There's more information about the back end, and then some more information about the runtime. I mentioned the Google Life Sciences API. It's still in beta, but it does replace the Google Pipeline PAPI software that we use today. And so there's an example of the documentation. A little more about preemptible VMs that we talked about. And finally, WDL Runner. This is the site on GitHub where you can take a look at the source there. So we'll build on this next week, and you can see that this was a little messy. There are challenges with with all these command line. You can see it. It's kind of fraught with real-time peril, and we extract again all of this and move it into Terra next week, and you'll see that a lot of this will be moving away, and I won't have all the messiness of worrying about environment variables and that sort of thing. Thank you for your patience as I work through that one. I'll stop for questions and see you. Oh, and Geraldine has joined us. Great. Hi, welcome. So Geraldine, I'll throw out the first question. When I was looking through the examples, you do a nice job talking about number of processors versus cost. And there is, when you're using Cromwell, kind of a startup cost to launching VMs, getting them set up and moving Docker images into them and that sort of thing. Is there ever a place where you kind of do a trade? Is there kind of a rule of thumb that says if I'm doing more than X number of samples, it always makes sense to use scatter gather as my algorithm. Or if I just want to get something done quickly and I only have X number of samples, is there kind of a trade-off there?
We haven't, I mean, yes, there are definitely trade-offs. We haven't formulated like a rule of thumb, like quick reference of the number of samples and this and that. Our data engineering group does a lot of testing to like for a given pipeline, for a given step, based on kind of the expected amount of throughput in terms of number of samples, the size of the samples, and based on testing of like what it takes for typical data. They kind of have that experience of trying it out and then figuring out based on that, like how widely to scatter. I'm not aware, I don't think they've done the exercise of formalizing that into like a set of rules, although that would be incredibly useful, if only for their own work. I think the hard thing is that it depends so much on so many factors. There's a cost to kind of doing that exercise of producing guidelines of that sort. I think it would be very, very helpful, and it'd be great also to have kind of input and experience from other people in the community who are using, like there's quite a few groups now who are using Cromwell at scale in production settings, and it'd be fascinating to have to kind of collect that information and try to derive some kind of references, because it is kind of where, like, when you can find the sweet spot of really balancing based on how quickly you want the results, based on like your budget, and a lot of things like that. It's really when you get to the sweet spot of balancing all the factors that you can get maximal benefit from how this is set up. Yeah, it'd be fun to kind of crowdsource like a community resource like that. I think that'd be really interesting. Something to talk about with the folks out there, for sure.
Okay, thank you.
I will say there are some steps in some pipelines where you might actually end up, I forget if we probably don't touch on that in chapter 10, but I think we discuss it a little bit later in the book, in the optimizations topic. There are some times you might actually put 2 or 3 operations bundled into the same whittle task, because you don't want to just copy everything, set up a whole new VM and copy all the data just to do that little operation. Sometimes you're better off doing everything locally on that VM if you have several steps before you move on. And I think that's where, especially if you're moving from a on-premises HPC and moving to the cloud, I think that's where a lot of folks kind of struggle a bit to transpose what they're used to doing in the cloud, because it's not just doing the same thing in a new environment. It's really, there are some things like that where you have to think about the different constraints. The factors and the balance of factors is different, and I think that can be challenging, but it's really worth thinking through, because you get to those sweet spots that I mentioned.
I don't have a question so much as a comment, which I think might be useful since we're talking about balancing cost and running time and stuff. Just to say the copy number variant project that I worked on in 2019, 2020, I ran all my jobs on preemptible VMs. So it's I can honestly say, like, it's fantastic. I mean, obviously, yes, it does happen that sometimes all your scattered jobs have stopped running, except maybe like 2 or 3, and you're waiting for those to stop running. But it really saved me a lot in terms of cost. So it seems like such a strange concept to let your VM be kind of like canceled from time to time, but it honestly, it's really worth it in terms of saving costs.
Right.
Yeah,
Yeah, go ahead, please.
No, I was going to say it's definitely like that. That is one of the most impactful things that you can do to bring the cost down, like that, because it's like a fifth of the cost, right? So right now, at least with current pricing, so the savings are amazing. And yeah, in our experience, it's worth, like by default, we let Cromwell retry a preempted job 3 times. And if it gets preempted 3 times, then we just switch to a non-preemptible. And all that is done automatically by Cromwell and can be adjusted, right? You can adjust the presets. You can also, and it's very impactful. For long-running jobs, I just want to surface this in case folks haven't heard about it. For long-running jobs, where it really hurts if it gets preempted, and you have to restart from scratch. Cromwell now supports checkpointing, which is regularly saving the outputs of a job while it's running. And then Cromwell will be able to use the checkpoint file to resume from the middle of the task, the point of interruption within the task itself, if the job has to be restarted. Now, it does require rewriting the task to use checkpointing, but it's a very, very important new kind of capability, I think, for very long running tasks, because it enables you to be more confident about using the preemptables. So that's pretty cool. There's a blog post about it. The Cromwell documentation has more details. I think it's currently only supported on Google, but I'm sure the others will follow in terms of implementing support.
Well, that's great. In fact, that was my question. So thank you for answering it. It was about checkpointing. And because we saw your post on Twitter about that recently. So yeah, that was really good. Also, is 3x just kind of an empirical, where does that number come from? If it's preempted 3 times and you're out, it's not a baseball reference. I don't think. Any guess there?
It's mainly based on, partly is empirical, that if you get preempted 3 times in a row, it means that clearly there's just like a peak of utilization on GCP right now. There's obviously a lot of demand, and if you keep using preemptables, you're just going to keep being preempted, so there's no point. And there's also, in terms of the cost calculation, if you think about when you have a preemption, you still get charged for the work that was done, even though it was useless to you. And so if you do that 3 times, you've already paid some amount of money, and trying more times is you're going to get to the point where you're going to end up paying more with the number of failed attempts than if you just used a regular machine. And so it's like, if it's happened 3 times already, let's just cut our losses and pay for a regular machine, and you still like end up paying a bit more, but you limit the damage. That's right. Kind of, and it's really about dealing with like periods of high utilization. That's it, in our experience, doesn't happen often, because as use increase, Google does increase their resource availability and whatnot over time. But it's really for dealing with these hot spots when they happen, I guess.
Fantastic. No, and that, as you mentioned, now that there's checkpointing, you're not losing as much work. Again, if you're 23 hours into a 24-hour job, you're now, right?
Yeah.
Worst case, right? So now it's not as bad as, and you've essentially you cut those costs by a lot, because you are now checkpointing. So that's a great new feature.
Yeah, and also in terms of, if you're in a development phase, the turnover is important. You can't afford to wait another 24 hours, because then that means that you, or the developer you're paying to do this highly qualified work, is now just sitting idle and costing you a lot of money while you're saving on the VM. And so it's like it's also the utilization of resources overall, counting not just the cost of the compute, but the cost of just not being able to progress in the work, which is non-trivial if we're thinking about like developing new machine learning algorithms. If you have a model building step that takes a long time, the more you can shorten that time, the faster turnaround you have, the more effective your development team is. And so that's more from the point of, if you're managing a team that's doing that kind of work, making sure that they're effective. And so traditionally, the way we did it was just not use preemptables for development work, based on the calculation that the developer time costs more than the machine time. But like checkpointing allows us now to go back to using preemptables for that work without paying a huge penalty in terms of turnaround time.
Interesting. Well, I'll pause for one more question. I had one more for you, but if our members have questions, this is a good time. We're coming up on our hour. Well, my last question is, oh, sorry, please. Go ahead.
No, I was just going to ask Geraldine if you think there will be a price difference between using just preemptables and preemptables with checkpointing, whether it will be treated as two separate things, and therefore there will be like a different, like whether Google will use, I don't know, maybe.
Well, the good thing is Google doesn't know anything about it. I mean, not that we're not talking about checkpointing. Presumably they'll find out that we're doing it. But the system doesn't know that we're checkpointing. We're just using a regular machine. And on the Google side, there's not actually anything that's done differently. It's Cromwell is doing a little bit of extra work. So that's the nice thing. It should not impact the cost of preemptables. And considering, like, you could think, well, is it going to influence Google's pricing as an indirect effect because of how utilization is, I don't think so, because the overwhelming majority of jobs are still going to be short running jobs, I would expect. So I don't think it would have that kind of knock-on effect on their business.
Excellent.
And Geraldine, if there is probably any better demo to explain why we should go to Terra, it was me giving a live demo today and working with the folks on the call to debug various issues that were mostly typing pilot error. And I'm guessing that a lot of these things go away in Terra. Can you give us a little preview of the next chapter and how this level of abstraction removes a lot of the fumbling that I experienced today?
Well, I did not witness any of that since I showed up late. But I would say, yeah, there's a complexity inherent in having to set up your own Cromwell, just directing Cromwell to talk to Google. The configuration we give you in the book is a basic configuration. There's a lot of additional things you can configure. You could, like, people who do it directly themselves would set up a Cromwell server and operate and have to maintain a server, and you have to send it instructions through REST calls. There's a lot of complexity, and you basically have to have a lot of know-how. There's a lot of little things that can go wrong, and it's also not really designed to be debugged by end users so much. Like, we kind of expect that there's a DevOps engineer in the middle who's I mean, not to talk down your capabilities or anything, but it is something that you expect to have, like, dedicated engineers running this kind of infrastructure. And so the nice thing with Terra is that all of that is done for you. There's a Cromwell server that's managed by a team 24/7. Like there's people with pagers who sometimes have to get up at 3 a.m. On a Sunday. We try to minimize that. Everything is set up so that things run fairly smoothly, but if something happens, somebody's on the hook. So it's a managed service, and you don't have to do any of that. There's actually, we say one Cromwell server, there's multiple Cromwell servers in Terra. There's load balancing. There's a lot that's done so that you can just, you know, say, this is my WDL, this is my data, hand that over to the system, and everything gets run for you. And it's not really about, people sometimes focus on the fact that there's a graphical user interface, web-based interface, and that's nice. And that's nice for a lot of reasons. But you can also use it programmatically through an API and just like write scripts that dispatch jobs to Terra. So you don't even have to use the point and click interface if you're not into that. But it's really the fact that the servers are managed for you and you don't have to worry about all of those details. Just like, here's my WDL, here's my data, here's how they fit together. Go run that for me. And I think that's one of the big strengths. There's a whole dimension of access to data through the data library, which is really important too. But in the context of this discussion, I would say it's the managed service. So it'd be interesting to get kind of your impressions as you work through the next chapter.
Yeah, very much looking forward to next week. I'll be presenting that as well.
Ooh, cool.
And so yeah, so I'm looking forward to that. And we're coming down to the home stretch. These few chapters, and then we walk into, after Terra, we get into Jupyter and the like. We have some more guest speakers, and we'll be coming up to chapter 14, reproducibility, before you know it. So I'm very excited about how much progress we've made. I know I have a lot more confidence with GATK, with Google Cloud at this point, and I'm sure a lot of our members are feeling the same way. It's becoming a lot more comfortable. So thanks for that.
Very cool, thank you.
Please join us again for the next meeting of the Genomics in the Cloud Book Club. We'll see you then.